Well, good afternoon. My name's Robert Braun, and I've been practicing in the automotive arena for just shy of 50 years. Actually, I entered the industry in 1978, and I have seen all the changes. Entered it in a very interesting time, at that point whenever the technology that we see today was just starting to come online. What it was so interesting because what we had is at that time when I was first starting to diagnose cars, we had test lights, simple circuits that we had to deal with. Carburetors were the norm. We did have electronic ignition was becoming very standardized, but we were still relatively simple. But I also watched as I entered the field, all the older guys said, I'm not working any of this electronic stuff, and they left. So it left a big void to learn and prosper. Actually, very interesting. Back in the day, I had actually recognized that I wanted to do this. And the very first meter that I bought is this old analog meter. Looks old at the time, or at this time now, but back in the day, this was state of the art. It was a number of paychecks to pay for this. And that got the momentum going for me to actually pursue a very good career in automotive. I think about that. In 1980s, we had the first electronic engine control systems come on, and the diagnosis for that changed. So this meter was my original meter I bought in 1978, but it had a relatively short lifespan because of the high impedance. That meter, being analog, drew too much current, and I was learning very quickly by the early 80s that you needed a high impedance meter. So I'd switched over to the snap-on line of meters at that point and continued to this day. So I had a chance to, of course, spend more money, put this in a box. It's still in its original, it's actually ironic, it's still in its original box from that era. So it treated me well, but it's long since been retired, taken off once in a while for things like this, show students and the like. Okay, well anyways, let's move forward. So as we went through the 1980s, computerization became more and more involved. We went from OBD1 to OBD2 by the time we got into the 90s, and that added a lot more. So scan tools really became a dominant part of what we needed to do and work on. I was heavily involved from lab scopes from even from the engine analyzer days. You know, back when we were just dealing with ignition systems. But over time, the lab scopes changed. They got faster, but so did the vehicles. So we had this dynamic that was taking place. Now let's roll forward. My experience right now, I'm working on hybrids and EVs. I'm pretty knowledgeable in CAN bus. I work all the way backwards. So it's interesting. I'll get calls for people working on old vehicles, the early versions of the computerization, and I'll get questions from them, and all the way up to working on a Toyota Prius. I got one hanging on a hoist right now. So figuring out that technology. So the industry can really treat you well, and that's really my objective here today, is to tell you about where the industry is and where it's going from this point forward, and how you can actually benefit. So back in the 1970s, that era, diagnosis you would look at as pretty much rudimentary, but at the time it was state of the art because we didn't have the points of reference. These points of reference came on over time. So when you're looking at grabbing a scan tool, we didn't have the luxury. I remember the first EEC2 systems. I remember the very first C4 and General Motors. Boy, you had a little, might take your analog meter and you'd see a little flipping, looking at the codes out of it, or it would work at vent solenoids, things of that nature. So it was a totally different learning. But the rules that you needed to know were real specific. They're the same ones today. If you understand Ohm's law, if you can read a DVOM, and you understand what the numbers mean when you're measuring ohms or volts. And really the key, and if I could give anybody a key today to go into the future, it was the key for me, was think voltage drop. Once you learned how to do voltage drop, it just changed the overall equation of what you needed to do out there. Think at a point of reference from a technician starting in the field in 1978 and moving forward, the art of voltage drop. The ability, that was one of the very first things I learned. With this old analog meter, I was doing voltage drop on power windows and seats and blower motors and wiring harnesses of all type back in that era. And that was one of the most primary skills that earned the money that I have made over all the years. It was a really solid income. A few other things, I'm not going to really talk about it here in any depth today, but learning how to use a torque meter, a torque wrench. Again, the pros versus the amateurs. So voltage drop, torque wrench, things are key to the industry. They have been and they will be going forward. I mean, I grab a torque wrench to tighten out the fasteners on EV batteries, when I'm looking at taking apart a transmission, anything that is used continuously. So things we need to consider. And the other thing too is, now grant you, we're talking literally from my points of reference are looking back literally 50 years as tech in the industry. So I've seen so much change. I've seen lots of people come and go. But the pros learned the basics, and once you understood the basics, it was moving forward. Moving forward at a really good rate. So again, let's kind of top this off here. So we started with analog meters were the dominant meter in 1978. By the early 80s, you needed a digital meter because of the impedance and the accuracy. Then came along late 80s, you absolutely needed an OBD1 scan tool. By the time you got into the later 90s, OBD2 came out, so many places your scan tool no longer was viable. You had to switch over to a more advanced scan tool. Then moving forward again, the need ever expanding to understand lab scopes, waveform analysis. So everything from vacuum waveform analysis, pressure waves, starting to really understand all the dynamics that are taking place within the electronic systems. Then today, now look at, we got all this wireless. Now we're looking at, I've been doing a lot of studying on AI systems. So these are all the transformations that are taking place. So it's been quite a ride, and it's been very interesting to see the transformation. But because of the fleet of vehicles out there, a given tech can be asked to work on something depending on what area of the country or how long the vehicles last. But if you're in a southern belt, you can easily have vehicles going back to the 80s that are more mainstream. So we could be looking at working on a 2025 just rolling out, or we could be looking at working on something in the 80s or 90s. Or if you're in the muscle cars, it could be something in the 60s and 70s. The tools that I invested, I think about that. I don't know the exact number, but it was I think like $150 I paid for this analog meter. That was a lot of money back in that time. You're just starting, you're not making much money, but I invested in what I felt was a high quality. You can see it was one of the things that I found was really interesting with this meter. And if you look at it here, this thing will actually go to 1,000 volt DC with these leads. These are original leads that were on it. So just imagine, now we are looking at category 3, we're looking at very specialized leads, very specialized meters, all the safety gear, the gloves and all that. And yet that meter at that time, so you can see how far safety has come along. But I just think it's kind of interesting because it will work easily on a HV battery. I have played with it. I just make sure that I have on my protective gloves. So that's one of the change. One thing we are as technicians today are significantly safer. Our tools work better, our safety gear is so much better, and that is something to always keep in mind. If you can make it through your career with your good eyesight, without losing a digit or any other injuries, and that's always been a danger, but you know, if you have safety up front in your mindset, it really does make quite a difference. Let's think about this here. 1970s, late 70s, timing lights and dwell meters were standard. That's something you had to have, and it was a standard operating procedure. And then you got into the single wire ECUs, simple codes. Then I went, as I said, into the OBD2. Everybody knows what bidirectional. I mean, just imagine at the time when you're looking at 1980s, if you could have the bidirectional control, the cars would have been almost like a no-brainer. And now we have remote diagnosis where everything goes into the cloud. So it all has its challenges. Things were many times harder back then and they were actually easier. So kind of based on a perspective. I think about ignition systems, and I really cut my teeth on that. That was one of the areas I spent a copious amount of time learning and perfecting, because that was the problem area of vehicles at that time. Tune-ups, where you'd be putting in points. You had burn-through distributor caps, plug wires, crossfire, all that. So running an ignition analyzer, studying waveforms for ignition was really the norm of the day. And then eventually we got into distributorless ignition, and as distributorless ignition came on, that started to change it. The ignitions became more and more reliable. Now we're down to repairing modules, and crank and cam sensors, things like that became more of a norm. And then you got into coil on plug, and our problem became less and less, so ignition became, and the longevity of spark plugs, from 12,000 mile tune-up to where we are now. Boy, I wonder if they ever got changed. It's got 150 on the clock. So that's where we are at. The ability for the vehicle to detect the slightest little misfire and give you the data that you need to do any maintenance, because maintenance really is, I hate to say it, but for the most part has fallen off. I mean, we know it shouldn't, but that's the industry. And now we're always in a reactionary mode. We're typically fixing a problem because it's gone beyond its useful life. So that's where the biggest mindset has changed. Then the next thing is back to my favorite of all, and that's parasitic draw testing. The tools you needed back in the day were a fuse puller and a test light, and then it moved over to a DVOM, and then we started getting into low amps probes, and then we got to start looking at scopes with low amps probes on them. So you started looking at dynamics there, interaction of the scan tool, and now where we're at with that is with the smart battery monitoring systems. You got to know what the computer is going to do and when it's going to take that load away. And now one of the tools of choice is my thermal imaging camera. So we go from that one extreme to another. But in my world, I still end up looking at some tractors and muscle cars and everything else. So the array of tools that need to be used, I use the latest and the oldest. And if you're entering this industry, think about if you're just coming to this industry right now as a young tech and pursuing, where are we going to go? Well, these are some really interesting things to think about. One item that I could emphasize the most on, and I'm just reiterating the point, so we're kind of in a long circle here. If you haven't learned electrical diagnosis, you're losing money. You need to become proficient. Don't think you're going to be able to make it through your career doing just mechanical work. I can assure you that will not happen. I've seen so many technicians enter the field. They were awesome. I mean, they could R&R a water pump, R&R a cylinder head. It was absolutely amazing, the speed. But over time, they ran up against the wall because everything has a wire on it, and more their jobs became so frustrated with that they could no longer be economically viable. I mean, sure, some do. I mean, there is jobs out there. I'm not saying it, but my observation has been if you can't do at least basic electrical troubleshooting and convey that information onto, say, an expert in the field, you're going to suffer. So at this point now, I guess it's almost obvious to go into this and get the electrical skills you need. But if you're thinking I can avoid it, my opinion is you can't. You're going to have to learn electrical and get the basics down. Don't worry about the advanced. I watch techs, they can move a scan tool around like it's a video game. Highly impressive. And then they get to a basic corroded battery cable and they're dead in the water. That vehicle goes literally unfixed. I find that to be almost humorous, but that's something we need to think about, is we got to learn the basics. People are high tech. Remember to go back to the basic. People that don't want to learn electrical have to at least learn it to that level. So the basic wiring, I think about that, the harnesses. One thing today is we don't have nearly as many wires. You got to look at the vehicles of that 70s and 80s. Boy, you take the Lincolns and the Cadillacs and anything like that. Man, the harnesses there were just huge. Now with systems like CAN bus, we just more and more wires have gone away. And now that we're putting, literally high-speed data right onto the sensors, more and more wires are going away. So now we're just making sure that we don't have noise, that we don't have voltage drop. Them things are going to be critical. But going through these looms that look like you were at some of these things were inch and a half in diameter, just completely filled with wires. That was the days, let me tell you. Them were the days. Okay, now what we're going to do is we didn't even know anything about hybrids and EVs and all that. But it's interesting, even back at that time, there was some people putzing around with electric cars. So there wasn't, and we all had electric golf carts. I have one here at my place I use every day. So I don't want to start a cold engine up on a golf cart or an ATV. So I take the electric golf cart literally everywhere. So that's made quite a difference for me. And so that's been out there. But now moving forward, we have the situation that we have to understand high voltage batteries, inverter diagnosis. I do actually a lot of that, and I'm kind of shaming some of the techs out there for not figuring out the things that they should be able to figure out. High voltage safety, as I talked about earlier, that is really a thing that I could say right now is to be successful in the field long term, think safety around this high voltage systems. It can reach out and it can hurt you, and we don't want that to happen. So keep that strongly in mind. Skills that are going to be needed. If basic electrical knowledge, computer diagnosis, oscilloscopes, understanding networking, and then as we're getting now into so much software diagnosis. So you got to learn something that I had to learn over time that it really has come about is paying attention to the data packs, the information going out there, and how, when you reprogram, what exactly. Don't overlook anything, because that's attention to detail. That's the same attention to detail as if you're looking at a waveform or ignition from an ignition analyzer in the 1970s. They look at every little nuance there. It's the same kind of nuances. It's the same thing, but we have to pay very close attention. And not all of us guys want to get in there and we want to start taking things apart. Sometimes you have to have the patience to read all the digits, make sure they all match when you're doing an update. So things to think about there. Now the wages, I look at that, and I don't want to throw out numbers, but the difference between just a basic tech and a diagnostic tech in the same shop can be, it could be, say an example, I'm just going to, a base tech can get $25 an hour. A high tech guy that can really solve the problems can easily be at $50 an hour, and it varies based on where you're at. But this is the kind of thing you got to think about, is your ability to earn a good, comfortable living, to update vehicles, to buy a nice house. All them things are going to be based in your hands on what your skills are. More and more we have many techs that are moving into the six-figure area. Very, very viable. It took a long time to get there for most of us, but now you can come right out of the box because the technology is so rough and there's not many people that can do it, that you can earn very rapidly. And so I think it's kind of a golden age from that perspective. The other thing you need to be aware of is understanding how to read manuals. We started out in the old books going through it, and actually the old books still work. I have a lot of them. But today we're getting down up to all the way up to AI-based predictive fault detection. I mean, I think about from an old Mitchell manual to where we have an AI system making a prediction based on all this data, life of the vehicle, and so on. So this is very interesting times to be pursuing the industry. Your IT knowledge. I'm envisioning very shortly here, technicians, some will actually get so specialized, they'll only live in the software area. That is going to be a reality. And if that's maybe your strength, maybe that is going to be where I was at in 1978, learning about the electrical and emissions, is maybe just becoming an absolute software expert will be the model. I'm not saying it is, but it does have a strong potential to be. And anything to do with EVs. Yeah, I think EVs are going to be here. I mean, I got Monster Motors. I'm very familiar with it. But I just look at that whole thing. I see the trend, and we are heading in that direction. I don't necessarily see it reversing. We'll have, I'm thinking I'm more of a hybrid guy than a full EV, simply because I look at the reality of distance traveled. The battery technology will eventually be solved. But until then, our friend, the gas engine will always be there, but in a totally different role that it had played once you get into a hybrid environment. So again, don't shy away from this technology. The best middle ground out there, and I think the biggest market share, at least for the foreseeable future, is going to be in the hybrid arena. So don't shy away from it. Embrace it, learn about it, be the best you possibly can be. Now let's think a few takeaways here. Electrical diagnosis is more critical than ever. Tools and technologies contribute to solving. So you need to make investments. Invest first in skills, secondarily in tools and equipment. Remember, primary is skills. However you determine to get your skills, but make sure you have to have your skills should always lead your equipment expenditure. As you get more skilled, you're going to need higher tech tools. They are usually more expensive. Don't try to put the cart in front of the horse. Do not go ahead and buy the ultra high tech tools, because that makes me look awesome, but I don't have the base skills. So avoid that. And the future belongs to those who embrace diagnosis and testing and are willing to learn. So I appreciate your time. Have a most wonderful rest of the day. Make sure you subscribe.